Brandon, here we are. We started this one yesterday, and we had it written on the beginning, on the front of day 3 work, so we didn't have a chance to finish it. We're adding vector A and vector B. We did it visually, and we guessed at the answer just by looking at the resultant. All right, now we're going to do it mathematically. This is our first edition of vector problems. So 34, the A is 34. I'll drop the units just so I'm not cluttering up my work. I'll put them in at the end at 45. So I needed the X and Y components. So I'm going to need your calculators out and on. And when I ask you for a step in this process, you can give it to me. So vector A is 34 long at 45 degrees. Make sure you're in degrees for this class because you need to be. So that's a mode button that will help you with that. So the X component is first, and we're going to do 34 cosine 45. Always cosine for the X component. So Emily Martin, what did we get for that one? We already did that.
44.
Right. And I put a little X there to make it clear to myself that's the X component. Then 34 sine 45 is the, also I remember this, Alex, you were surprised that it was the same, but that's,
yeah, I was like, huh?
That's one of the secrets of the universe. 45 always happens, the same X and the same Y. Alright, so that's why I remember that. So now we're going to work on vector B, and I think that's about where we were. So Emily Davis, oh, I'm trying not to say last names.
It's okay.
Oh well.
Emily David.
Alright, so.
My name.
For legal issues?
No, just protection, because it's going up on YouTube.
Oh.
So, alright, so Emily number 2. What is 20? It's not 45. What is it? See, that's where I said sometimes we do things that are really stupid and don't realize it. So, Emily, 20 times the cosine of 123.
Drop code names.
And just to the nearest whole number.
-10.
Or you say
Negative 11.
Negative 11. Alright, I'll go with it. Alright, over to you, Zach. We're going to in the Y component. So it's going to be 20 sine 123. We'll just go to the nearest whole number.
17.
17?
Mm-hmm.
17 is the Y. Alright, so when we add vectors, it'd be really nice if we could just add their magnitudes and add their angles and be done with it. But it's not correct. So what we have to do is take each magnitude and angle and divide it into X and Y components. X and Y, oh that is X. Let me put a line there. X and Y components. And we're going to add X to X and Y to Y. And that is why I asked you to line them up this way. So if you do, they show up on top of one another. So Emily Keene, 24 and negative 11.
13.
And Brian, 24 and 17. So this is my X. I've just put in X just to remind myself. There's not a true X variable sitting there. It's just an X value that reminds me that's the X component. Brian,
17.
24 and 17.
41.
All right. So when you add vectors, you must be in X and Y components. X to X, Y to Y. All right. Are we done? When the teacher says that, the answer is always
No.
No. So what we have here is a situation where the X component is 13. So I'll go out somewhere and call it 13. And the Y component is 41, so it's quite a bit larger, relatively. So the answer would be right there. I want the angle, I want to go back to magnitude and angle from which I started. So let's review that. I'll point to you. You tell me what you always do. This group?
Pythag.
Pythag.
Inverse
Inverse
tan.
tan. Adjust. All right, again.
Pythag.
Inverse tan.
Adjust.
Okay. All right. So we're going to do that. We're going to Pythag inverse tan and adjust. So go ahead, throw this into the Pythagorean theorem, looking for the hypotenuse we call C. And I'll need that out of your calculator, Alex.
Yeah,
So,
I got you.
after you get that,
So by adding the cosines of
No, that's a
both
43.
vectors
uh-huh.
and the sines of both vectors,
Right.
we get the cosine and sine of the third vector.
Right. We get the x and y component of the third
Okay,
vector,
so
right?
what did
So
she
you're
do?
right.
Oh,
So third, now we're taking that and we are squaring 13, adding it to the square of 41,
43.
and then taking the square root.
And equals
We
43.
need to do it now for me to get this.
You got what?
43.
43? Sounds healthy.
We did it
43, and now we need an angle, so inverse tan.
Oh, we have the inverse tan.
Alright, inverse tan is going to always be the opposite over adjacent, and that will always be the y component divided by the x every single time. So y divided by the x, so that's why I kept asking you mark it as x, mark it as y, because then you'll know when you get here. So, Hunter, tan inverse, make sure you're in degrees, 41 over 13.
72.
72. So here's the form. I wanted you to use the final answer is 43. That was from the Pythag. And what were we starting with? Meters per second. Now I'll go and put my units in. Angle box, 72. All right, how was our guess
close.
in the beginning?
Pretty close.
Not too bad. Not too bad. The angle, I figured the angle would be a little off because we're working on the board with vectors that aren't really proportional to the problem. So I'd say that was pretty good. It's reasonable. It shows me my answer is probably
I
correct.
guess that's 45.
All right, that's the last vector problem you're going to see
Yeah.
without words.
Oh.
So vector problems don't make
I went
much
over that.
sense if you're just saying add this vector to this vector. So we're going to match vectors to a set of words. And as I erase all this, I would like you to jot this down on day 4. So we're going to do more addition of vectors,
Like 2 again.
break down the problem, and then sketch it. Alright, I guess we forgot the time again.
Yeah, we did. We probably
Alright,
could shut
after
down
he
on
writes that down, or show him that problem
I
up
have
there, and you can show him the sheet, and then you can just shut it down and start again after we
Write this problem down again.
writing this.
Well, how did that?
Yeah.
Alright, Brandon, what's your
Not
day
gonna
4
do-
notes look
This should
like?
be already in your notes now. Anyone need
So working at
this?
75.
Hunter, Alex, Brian, did you get all this?
Yeah,
May I
that's
erase
great.
The
it?
basic
Yeah.
formula thing.
Anything else?
I'm good. Good.
Okay.
It's all Gucci. It's all Gucci.
Super Giuseppe.